Hi, welcome to my video on simplify rational trig expressions. Rational trig expressions are the same as rational when you have fractions, expressions with numerator, denominator, with x's in them and y's, etc. So now we have rational fractions in which you have sine, cos, tan, and all the other trig functions. So let's do some examples. We have two fractions, and when we add fractions, which we're doing, we need a common denominator. So the common denominator is cos theta, common denominator is cos theta. So we write down the denominator and we add the numerators. But these two terms are not the same, so we just got to write them down. We can't add them together. B, we have, again, two fractions that we're adding. We have a common denominator of 2. Write it down. And we add. These are two terms that are the same. Cos theta. So 1 plus 1 is 2 cos theta. And after adding, we have a 2 on the top and the bottom. We cancel, and we just get cos theta. C. Again, we're adding fractions. We need a common denominator, which we have. So the common denominator is cos theta. We write it down. And now we have 3 sine subtract sine. So 3 subtract 1 is 2 sine. And this later on, when we do more videos on the trig expressions, we'll be able to simplify this a little bit further, but for now, let's leave it like that. And D, we have two fractions again. We have common denominators, sine cos and sine cos. So we write down the denominator, sine cos, and we add the numerators. Again, we can add these because they're both cos thetas. 6 plus 2 is 8, so it's 8 over cos theta. But because we have a fraction in which we have 8 times cos and sine times cos, there's common factors. Cos can cancel out, so we get 8 over sine theta. And what we have here is some practice. Practice means pause the video and work out the answers, and when you get them done, press play to see if you have them right. The first one, common two fractions, same denominator, so let's write down the denominator of sine theta, and we add 2 plus 3 is 5, 5 over sine theta, and simplified. And number 2, we have two fractions, and notice the denominators are both cos, but we have a subtraction. So if we have a subtraction, then what we could do is let's add on the opposite. So cos theta, because we're subtracting, we're going to add on the opposite, which is the negative cos theta minus 1. So notice the subtraction sign is changed to a positive sign, so we make cos theta negative and plus 1 negative. Now we have the same denominator, cos theta, in each fraction. So now we have 3 cos theta plus 1, add on negative cos theta minus 1. And when we add the cos thetas, 3 subtract 1 is 2 cos theta. And we have positive 1, negative 1 is 0. And notice that the fraction cos theta is on top and bottom, so we cancel. So we get 2 as our final answer. Number 3, again, we're subtracting, so this is only a monomial here. So the common denominator is 6, so we write that down. So they're the same terms, so 11 sine, and when we subtract, we add on the opposite, which is negative 7. So 11 subtract 7 is 4, so it's 4 sine theta. And we have a common factor of 2, so 4 divided by 2 is 2. 6 divided by 2 is 3. So we get 2 sine theta over 3. Or we could also have 2/3 sine theta. Either or will do. And number 4, we have adding two fractions again. The common denominator is sine. And we add 1 plus cos theta. But we can't add those because they're not like terms, so we just leave them separate. So 1 plus cos theta over sine. And let's continue. Now, another part of adding fractions or rational expressions, which is integers or in algebra, we need equivalent fractions, because if we have two fractions that have different denominators, we need to make them with the same denominator. So let's have a bit of fun. And 1 over cos, and what do we need to put on top of cos squared to make them equivalent? Well, cos squared is cos theta times cos theta, because cos theta times cos theta is cos squared. So we put cos theta on the bottom, we put cos theta on the top, that's a 1. So 1 times 1 over cos theta makes it equivalent. So 1 times cos is cos theta. So 1 over cos theta is the same as cos theta over cos squared. And so we're making denominators equivalent fractions. And the same here, we have a fraction. This denominator is sine squared. So what do I need to multiply sine theta by to get sine squared theta? I need sine theta. So if I put it on the bottom, I also have to put it on in the numerator, make it equivalent. So 4 times sine is 4 sine theta, and sine theta times sine theta is sine squared. Again, we're looking for equivalent fractions. So I have a sine on the bottom here, sine theta. I have a sine theta cos theta, so that means this sine is multiplied by cos theta in order to have this expression. That means I multiply the numerator by cos theta. So cos theta times cos theta gives me cos squared theta. And sine times cos is sine cos. Made it equivalent. And D, this denominator is 2 cos theta. This one has 2 cos theta sine. So we need an extra sine theta. And so we put sine theta in the denominator. We have to put it in the numerator to keep it balanced. So sine times sine is sine squared theta. And the denominator, when you multiply it, is 2 cos sine. Perfect. So you can see how we're making equivalent fractions. And it's the same thing we did when we have algebraic expressions with x's and numbers, etc. So practice, complete each. So pause the video and work these 4 out. Here we go. What do we multiply sine by to give me sine squared? Well, it's sine. Sine theta on the bottom, sine theta on the top. So 1 times sine is sine theta. Sine times sine. Sine theta is sine squared theta. And here I have a cos theta on the bottom, and I have a cos theta sine theta. So that means that this fraction was multiplied by sine theta in order to get this expression. So that means I multiply the numerator by the same term. So that's sine times sine is sine squared. And looks like my pen just ran out. I have a new one here. Okay, hopefully this one works. Good, I got it. And we want cos, and cos is understood to be over 1. So what do we multiply 1 by to get sine? So it's sine theta. So that means the numerator is multiplied by sine theta. So 1 times sine theta is sine theta. Cos theta times sine theta is the numerator. So we made them equivalent fractions. And this one, we have a fraction. What's the numerator we have to put here? Well, sine times what will give me 3 cos theta sine theta. It has to be 3 cos theta. And the numerator got to be 3 cos theta to make it equivalent. So cos theta times 3 cos theta is 3 cos squared to make it equivalent. Okay, notice when you multiply these two, you get 3 sine cos, or cos sine. When you multiply these, you get 3 cos squared. And you notice after you have this fraction, you can reduce this back, cancel the 3's, cancel the cos's, and this will be cos over sine. So even though I'm building them up to get equivalent fractions, you can reverse it and cancel. Okay, more examples. We have a fraction and a whole number. Remember, 1 is understood to be over 1. The common denominator for these two fractions, this is a cos theta, this is a 1, so the common denominator is cos theta. So that means that we have 1 over cos theta, and 1 is the same as, we need a common denominator, which is cos theta. So cos theta divided by cos theta is the same as 1. Since the common denominator is cos theta, write it down. And we add these, 1 plus cos theta. And in B, we have two fractions. The denominator of this one is sine squared theta. This one is sine theta. We need them the same, so the LCD is sine squared theta. That means that this one is multiplied by sine theta over sine theta. And notice now we have 1 over sine squared theta. Add on. Sine times sine is sine squared theta. And 1 times sine is sine. So notice now, multiplying by sine theta over sine theta gives us the same denominator for both of these. The common denominator is sine squared theta. And we add 1 plus sine theta. We cannot combine these because they're not like terms. And number 6, we're subtracting. So in subtraction, we add on the opposite. Okay, that's done. The common denominator, the LCD, the denominator here is cos, the denominator here is cos theta sine theta. So the common denominator has to have cos theta and sine theta. So this denominator is the common denominator. So that means we're going to multiply this one by sine theta over sine theta to make it equivalent. So multiply. So we get 2 sine theta all over sine theta cos theta. Add on -1 over cos theta sine theta. Now note, even though I multiplied by sine cos, and this is cos sine, these two denominators are the same. Remember, 4 times 5 is the same as 5 times 4, because in multiplication you have the commutative property. So these two denominators are the same. They're not written down the same, but they're the same. So we have sine theta, cos theta, and now we gotta add these. So that's 2 sine theta minus 1. We cannot subtract these, can't combine them because they're not like terms. And in D, this denominator here is sine, this denominator here is cos, so the LCD is, you have to have sine and you have to have a cos theta. Both of these have to be in the LCD. So that means this one is multiplied by cos theta over cos theta, and this one is multiplied by sine theta over sine theta. And when we do, we get cos times 1 is cos theta. And I can write the two of these the same now, so actually I have them written down. So notice 1 times sine is sine, and cos theta, sine theta. The two denominators are the same, therefore we write down one of them, and as a result we add these together, but we can't combine them because cos theta and sine theta are different terms. So that's finding, adding when the denominators are not the same. We have to make them equivalent. So that's why we did this practice up here, how to write equivalent fractions. And now we need these denominators got to be the same. So hopefully you understand. So it makes no difference if it's x and y's, a's and b's, or what. We have to have, when we add and subtract fractions, we need common denominators. And that's in the unit on rational expressions, dealing with the x's and numbers and trinomials and binomials, etc. And we have extra practice. So pause the video and work out each of these. And again, as you do each one, do one at a time to see if you're going to be right. We have two fractions. Common denominator is, that's a sine squared and that's a sine. So the common denominator, the LCD for these fractions is sine squared theta. That means I multiply this one by sine. And sine on top and bottom make it equivalent. So we have cos theta over sine squared theta. Add on. Multiply the denominators, you get sine squared theta. Multiply the numerators, we get sine theta, because 1 times sine theta is sine theta. We have the same denominator of sine squared theta. Write it down. And we add. We can't combine them because they're not like terms. Okay. And number 2. So we have 1 over cos theta subtract 2. So that's 2 over 1. And because we're subtracting, we can add on the opposite. So now the LCD for these two fractions, there's only one denominator, and it has to be cos theta is the common denominator, there's only one. So that means you got to multiply this one by cos theta. And to keep it equivalent, we got to put cos theta on top and bottom. And this fraction is okay, it's already the same denominator cos theta, and 1 times cos theta is cos theta. Negative 2 times cos theta is a negative 2 cos theta. Common denominator is cos theta. 2 of them are the same, write down one of them. And we subtract these, so 1 subtract 2 cos theta. Again, you can't combine them, but they're not like terms. Number 3, what is the LCD? Well, this one has a cos theta sine theta. Okay. Write that down. And this one has a sine. So this sine is already a part of this denominator. So the common denominator is cos theta sine theta. That means that this fraction has to be multiplied by cos theta. And that makes it the same as this, so, but we have to balance it, so we got to put a cos theta over cos theta. So that gives us 1 over cos theta sine theta. Add common denominator, and now you could say sine cos, but I can write it the same as the first one because sine times cos is the same as cos times sine, and the numerator is cos squared theta, cos times cos theta times cos theta is cos squared theta. And we have the same denominator, which is cos theta sine theta. Notice the two of them are the same. And we add, but we cannot combine them because they're not like terms. So it's 1 plus cos squared theta. And number 4, the LCD, you have to have this denominator, which is cos theta, and you have to have this denominator, which is sine theta. So this one is multiplied by sine theta on top and bottom, and this one is multiplied by cos theta top and bottom to keep it equivalent. And notice we have a subtraction, so we add on the opposites. So let's make that plus -1. So multiply cos theta times 1. Sorry, sine theta times 1 is sine theta. Sine times cos, or sine theta times cos theta. Add on. -1 times cos theta is negative cos theta. And sine times cos, can't multiply them. They have the same denominator, which is sine theta cos theta. So we write down one of them, keep the denominator, and we subtract these, but we can't subtract them to combine them. We can subtract them all right, but we write them down as two different terms, so sine minus cos. Number 5, now we have to add these. Let's put the sine over 1, so the LCD is, there's only one denominator, and it's cos theta. So that means this fraction is okay, because it has the denominator of cos theta. So that means this one is multiplied by cos theta over cos theta. So multiply the 1 times cos theta is cos theta. Sine theta times cos theta. There it is. And the common denominator is cos theta, so we write it down. And 1 plus, you can't combine them, so it's 1 plus sine theta cos theta. Again, same as in algebra, same as the rational expressions with the x's and then variables of the y's and numbers. Okay, now we have to obey what we call, when we go to do order of operations, PEMDAS, or bed mass. There's no, the 1 over sine can't be simplified. There's no exponent. E is for exponent, but we have to multiply before we add. So cos over 1 times 1 over sine. Cos times 1, cos theta times 1 is cos theta. 1 times sine theta is sine theta. And that's cos theta over sine theta. So we multiplied first, that's done. Now we add. And they have the same denominators. So both, they got sine theta, so we add. So 1 plus 1, there's 2 cos thetas. Again, later on this will simplify further if we wish, but right now I'm not worried about it. Just trying to show you that when you subtract or add fractions, you need common denominators, equivalent fractions, etc., etc., etc. Okay, and we got PEMDAS again, PEMDAS. And there's no brackets, no exponents, but we have to multiply before we subtract. So we got sine theta over cos theta, and we're multiplying these two. And notice when we multiply fractions, we can cancel. Sine cancels in the sine once, so that gives us 1 times 1 is 1 over cos theta. And we're subtracting, so we can add on the opposite. And the common denominator is cos theta. And sine minus 1. We can't combine them because they're not like terms. And again, PEMDAS, I keep writing it down to make sure you know about the order of operations. There's no brackets, there's no exponents, but we have a division and a multiplication and addition. And we have to do the multiplication and or division left to right. So I have to divide these two and multiply these two. So this is sine over 2, sine theta. When we multiply, when we divide fractions, we multiply by the reciprocal. So notice I turned sine cos upside down, reciprocal. So I'm doing the division now, and I could write this one down again. Done. So notice I did the division, I did the reciprocal, multiplying by the reciprocal. Now I have to do multiplication before I add. So I cancel the fractions here. So that gives me cos theta over 2. And I have to cancel here. And that gives me cos, when I cancel I get 1 and 1. And 1 and 1. So 1 times cos theta is cos theta. 2 times 1 is 2. Cos theta times 1 is cos theta. 1 times 3 is 3. Now, I need a common denominator because I'm adding fractions. Common denominator for 2 and 3 is 6. So you multiply this fraction by 3 over 3. You multiply this one by 2 over 2. Common denominator, you have a 2 times 3 is 6. That gives me 3 cos theta. And 3 times 2 is 6. And cos theta times 2 is 2 cos theta. And both fractions have the same denominator of 6. And we can add these, yes, and we can combine them because you got cos theta, cos theta. So that's 3 plus 2 is 5 cos theta. So that could be your answer. Or you could have 5 over 6 cos theta. Either or. So that's working out and simplifying rational trig expressions with common denominators. So it's a skill that you'll need at the end of this unit when we go to do identities. You have to combine, add fractions you need to make them equivalent, and you need to get the same denominator. Hopefully you enjoyed the video. If you did, click the like button, the subscribe button, the notification bell. Visit my website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content that's on my YouTube channel called Math Fully Explained. Thank you very much for viewing my video. Bye-bye.